We want to talk quickly about graphs of power functions. Power function is a function of the form y equals f of x equals x to the p. So here we have x, here we have y. Now, let's say that y equals x squared. Well, we see that we have values of 1, 1/4, and 2. This is all we need. We could easily fill in the rest of the table by the symmetry. In other words, if x is 1, since x squared behaves the way we know it does, it's going to have the same value as it does at -1. It's also going to have the same value at -1/2 that it has at 1/2. It's going to have the same value at -2 that it has at 2. And of course, at 0, it's 0. So actually, we should probably go ahead and include 0 here. So from this information, knowing that f of -1 is 1, and that f of 1/2 is 1/4, and that f of 2 is 4, and knowing that the shape of this thing is symmetric with respect to the x-axis, we don't really need the other points. We can draw the graph. And it's going to work out. 1 is going to correspond to 1. If we come over here, we're going to see that -2 corresponds to 4, and so forth. Now, there's no reason you can't make the complete table. What we want to focus on is how varying the power varies these values. So if we just do kind of a multiple graph here, if we do y equals x cubed, what do we see? We see that when y is -1, x is -1. When y is 1/2, x, instead of being 1/4, is 1/8. When y is 2, x is 8 rather than 4. When x is 0, y is still 0. So we could graph this function. I probably should have used a different color chalk here, but I just put a big green circle around it and use green chalk down here. Okay, there's the 0, 0 point. The 2, 8 point, well, it's way up here, so I'll mark it. The 1, 1 point, every power function is going to have value 1 when x equals 1. We know that. When x equals -1, of course, that takes the function down here into negative x values. So here we have y equals -1, and so forth. So the graph is going to come down like this. Here, oh yeah, and at 1/2, we're going to have 1/8. Okay, so it's going to flatten out even more than the x squared graph. Then it's going to do the same thing on this side. It's going to be very flat, and this is going to get very steep. And there's our graph of x cubed. Now I'm not going to draw the graphs. I'm going to ask you to do that for homework. Okay, we have y equals x to the 4th. What's that going to look like? Well, my value at 1 is, again, 1. -1 to the 4th is 1, because multiplying 4 negatives together gives you a positive. We have 1/16. We have 16. And of course, we still have 0. Now, if I graph these points with colors, I'm going to still have the origin. I'm going to have a point even closer to the x-axis here when x is 1/2, and when x is 1, I'm going to get 1, and it's going to be even higher up here. So, and it's also going to be symmetric, because -1 is going to give us 1, so we're going to go through this point. So it's going to come down from way up here. I'm going to just kind of trace that lightly. It's going to be very steep. It's going to come down here and go through this point. It gets very flat down here. Then it comes up here, and then it takes off and goes way up here. Okay, so there's our graph of x to the 4th. something very much like this. Okay. Graphs get increasingly steep in the first quadrant. What happens at -1 tells you whether you have a symmetry on this side, a symmetry with respect to the y-axis, or an anti-symmetry like the x cubed graph, which is a symmetry with respect to the origin. If we go to x to the 5th, I'm not going to write the values, you can write them in. I'll probably ask you to do that for homework. Okay, and we'll do this one in orange. It's going to be even higher, twice as high as this one, too high for me to reach. But it's going to come all the way down to 1. That's going to come down to twice as close to the x-axis as this blue graph. It's starting to look like the graph is almost on the x-axis here. Going to go through the origin. That's going to go through -1, -1. You verify that by calculating this. So it's going to come down very steep here. It's going to come down here and really flatten out. Going to get almost flat here, but not quite. And it's going to look something like this. Okay. Well, we have to know how to graph these, and I hope I've convinced you that knowing the values at just these few points, we can reason out everything else. You can always make a complete table, but it's not necessary if you understand what the values at these points are telling you.